Hi guys, today we're going to continue on the notes that we started the other day on solving and graphing inequalities. So we looked at just a review of how we represent inequalities, how we solve inequalities, and how they're graphed. And then we had approached this section on interval notation, which I'm going to review with you and continue. So we had said that interval notation is a way to represent a solution set, a different way of representing a solution set than what we have before. So we had the inequality itself. So if you look at example 13, I'm just recapping. We had the inequality itself, and we have the graph of that inequality, which looks like this. Here's -5, -6, and -4. X is greater than -5 means all numbers that are to the right of -5, but not including -5. And to express that in interval notation, what we do is we say x could be any number from -5 all the way till positive infinity. And we put parentheses around each of those to indicate that we're not including. Okay, so parentheses mean we're not including those numbers. So we're not including -5 because it doesn't have an equal sign and it has an open circle to show that. And we're not including infinity because infinity is not an actual number. It's a concept. It cannot ever be actually included. Okay, now if you contrast this example with example 14, which is x is greater than or equal to -5, on a number line, that graph is the same except you are including -5. So the -5 gets colored in, and it's still anything greater than -5, but this time or equal to -5. In interval notation, that's still going to be -5 to infinity. It's saying any number from -5 to infinity, but this time I'm including -5. So I use a bracket, a hard bracket, to show that I'm including the number. Parentheses around infinity because infinity can still never be included. Okay, so hard bracket, which is that squared off one, means not including, excuse me, means we are including that number. Okay, now if you look at less than, then you're just basically moving in the opposite direction. So a graph with x is less than -5 will look like this. It'll be all numbers to the left of -5. This time we're not including -5. So interval notation would be any number from -infinity all the way up to -5. So because we're on the left side now, we go from least to greatest. So the smallest possible value of the number is -infinity, and it continues all the way to the largest possible value, which is -5, but not including -5. So we put parentheses. And then the last one is similar to this one, but this time we are including -5. So x is less than or equal to -5 means any number to the left of -5, but this time could be -5. Okay, so we have an interval notation, any number from -infinity all the way on the left all the way up to -5, including the -5 hard bracket. And you can never include infinity or -infinity for that matter. All right, so that's a recap from last week, which we had gone through very quickly. And now we're going to apply this to where we have to solve the inequality, graph it, and then express its solution set in interval notation. So if you look at example 17, I'm going to solve, meaning I'm going to isolate the variable. So I will add 12 to both sides. I get -3x is less than 33. Divide both sides by -3. Remember, when you divide by a negative, you switch the inequality symbol. So this becomes x is greater than -11. So on a number line, I have -11, -12, -10. I usually just put 3 numbers on my number line. And then x is greater than that. So open circle, greater is to the right. Now, you might want to pause the video and see if you can write this in interval notation. Okay, so in interval notation, this is all numbers from -11 all the way to infinity. And we're not including -11, so it gets parentheses. All right, we're going to look at one more like this. Example 18 contains fractions. Inequalities with fractions are just like equations with fractions. You want to clear your fractions first. Okay, so my LCM is 12. I'm going to multiply each term by 12. Times 12, times 12, times 12, times 12. So I'm going to divide 12 divided by 3 is 4, times 2 is 2x is 8x. And then I have negative 12. Bring down your inequality symbol. 12 divided by 4 is 3, times 3x is 9x. And then 12 times 2 is 24. So I'm going to isolate x. I'm going to bring my x's to the left side. Even though it gives me a negative, I just prefer to have them on the left. I have negative x minus 12 is greater than or equal to 24. I'm going to add 12 to both sides. I'm going to go over here. I have negative x is greater than or equal to 36. And this negative is a negative 1, so I'm going to divide by negative 1. And remember to flip the inequality symbol. So x is less than or equal to negative 36. So on a graph, here's negative 36, negative 37, and negative 35. And x is less than or equal to it. So including the negative 36 or less this way. So take a pause and see if you could write this in interval notation. In interval notation, this is any number from negative infinity, all the smallest value, all the way up through negative 36. I'm including negative 36, so I put a bracket on it. I can never include infinity. Okay, so this should help you guys with homework tonight. Use your notes, and I'll see you tomorrow. Thanks.